Now we're going to look at circles in polar form and their corresponding rectangular functions. So here we have a polar function that makes a circle, r equals 10 cosine theta. This is the one we looked at in homework. Here's the rectangular function that has the same form, y equals 10 cosine theta. So let's think about what the 10 tells us in both equations. In the rectangular function, the 10 tells us the amplitude of the graph, or the farthest that the graph gets from the x-axis. In the polar function, the 10 tells us the largest value that r takes, the largest amount that the graph varies from the pole, or the center of the polar function grid. Let's look at some specific points here. This point would be the point 0, 10. In polar form, we would write that in the other order, 10, 0. 0 being the number of radians, this would be the angle, and 10 being r. So at 0 degrees, we're at 10, and the radius is 10 here. Now, if we go down to another fairly nice point here, we have this point pi over 3, 5. This would translate in polar form to 5 pi over 3. So 5 pi over 3 is the point that has a radius of 5 at an angle of pi over 3. That's that point here. Then we go to pi over 2, 0. That would correspond to a point that has a radius of 0 and an angle of pi over 2. So if it has a radius of 0, it's just right at the origin. Now let's go down here to 2 pi over 3, negative 5. So 2 pi over 3, negative 5. Now we're starting to get a little trickier, because if we were at 2 pi over 3, positive 5, we would be right here. But we're at 2 pi over 3, negative 5. So we have to go the opposite direction of 2 pi over 3, which is in the direction of 5 pi over 3, and go 5 units there. Okay, so opposite of 2 pi over 3, go 5 units, and we end up right here. So this is the point negative 5, 2 pi over 3. If it had been positive 5, 2 pi over 3, I would have been over here in quadrant 2, but now I'm ending up down in quadrant 4. Our next point is pi negative 10, which ends up being negative 10 pi. I'm sorry, yeah, negative 10 pi. So positive 10 pi would be going out 10, rotating to pi, so it would be right here. It would be in the direction of pi, 10 units. But if it's negative 10 pi, then I go back the other direction, and it's in the same place as 10, 0. So this is the same as negative 10 pi. So basically, I have started over again now with the same, with a point going around. I've gone all the way around and back to the start. So let's look at what we have in the rectangular graph. Notice here r is decreasing as I go from 0 to pi over 2. Here, as I go from 0 to pi over 2, r is also decreasing. Now, if we think vertically, we think, oh, it's going up and then down, but no, it's not. Think about how far r is from the center. Notice that as we move around from 0 to pi over 2, r gets smaller and smaller until it gets down to 0. Now we're in the quadrant 2 angles from pi over 2 to pi. Notice that all of these r values are negative. So as I rotate around into quadrant 2 and I look at the quadrant 2 angles, r is negative. So that means all the points corresponding to these angles are actually plotted in quadrant 4. So what I want you to notice here is in quadrant 2, y is less than 0. Here in quadrant 2, r is less than 0. So that means the points are plotted in quadrant 4, because in quadrant 4 is in the opposite direction through the center of the circle, or through the center of the polar grid here. It's in the opposite direction from quadrant 2. Now when we get to quadrant 3, we have some quadrant 3 here, we have 4 pi over 3, negative 2. So we have another situation where we have a negative radius. So if we went to, or not negative 2, sorry, negative 5. Thinking of the wrong graph. Negative 5. So if I went to 4 pi over 3, so if I go out positive 5 and rotate around to 4 pi over 3, I'd be right here. But if it's negative 5, that means I have to go the opposite direction, and I end up back where I started. I ended up back on the same point as I had before. This is also the point -5 4 pi over 3. Then I get back to 3 pi 0, which is the same as 0 3 pi. Okay, so 0 3 pi over 2. Sorry, 3 pi over 2 is right here. And then I'm up at positive 5 pi over 3 positive 5. And then I'm at 2 pi positive 10. So 5 pi over 3 positive 5 is right here. Positive 5 5 pi over 3 is the same place as -5 2 pi over 3. And of course 2 pi 10 is the same as 10 2 pi here, 10 0, same point. So this the curve that's this curve going down corresponds to this top part of the circle. The curve from pi over 2 to pi is this bottom part of the circle, and then this curve going up in quadrant 3 is corresponds to this top part of the circle that's flipped over from quadrant 3, and I actually forgot to write this down. Quadrant 3 y is less than 0. Over here that means quadrant 3r is less than 0, so the points are plotted in quadrant 1, because quadrant 1 is in the opposite direction as quadrant 3 through the center of the polar grid. So this section of the graph right here, that's quadrant 3 angles, is actually plotted again in quadrant 1, and then this section that's quadrant 4 is plotted down here. So going one cycle of cosine actually takes us 2 complete times around this circle. Now, how is the sine version of this graph going to be different from cosine? Well, let's not plot quite so many points, or at least plot them a little more quickly. So here's a point 0 0, so that's going to start us off. Then we're at pi over 6 2, so pi over 6 2 would be right here. Then we're at pi over 2 4, so pi over 2 4 would be right here. Then we're at 5 pi over 6 2, which would be right here, and then back down to pi 0, so that gets me back to where I've started from. So basically I'm making this loop all the way around and back to where I started. Now when I hit these negative values, okay, these are all quadrant 2 or quadrant 3 and 4 angles. For between pi and 3 pi over 2 would be here. Between 3 pi over 2 and pi would be here, but all of these have negative r values. So 7 pi over 6 negative 2 would end up being back over here again at, kind of heads back over here, and it's at pi over 6 positive 2. And 3 pi over 2 negative 4 turns out to be pi over 2 positive 4. And 11 pi over 6 negative 2 ends up being at 5 pi over 6 positive 2. So when we get to this section of the graph that's below the x-axis, we end up plotting on top of the points that we already have. So this is a sine polar function circle graph. Now what would happen if a is less than 0? A is the number that we're multiplying here. So for example, if this were r negative 10 cosine theta or r negative 4 sine theta. So if we have r equals negative 10 cosine theta, that means every value that I've already plotted, the r value would be the opposite of what it is. Think about what happens with the actual cosine graph. The actual cosine graph would turn upside down. Instead of being like this, it would turn upside down and be like this. So all of the negative r's would be, negative y's become positive and vice versa. Same thing here, all of the negative r's would become positive and vice versa. So that means for the cosine graph, this point over here would flip over to here. This point would flip down to here. This point would flip over to here. So instead of being in all the points being in quadrants 1 and 4, all the points would end up in quadrants 2 and 3. All of the quadrant 4 points would end up in quadrant 2. All of the quadrant 1 points would end up in quadrant 3. For the sine graph, we would switch So that means I'll just go ahead and draw it. So that means that the circle would end up being over here instead. Now if we do r is equal to -4 sine of theta, think about our sine graph. Our sine graph that normally goes like this would turn upside down and go like this. So all of my positive r's become negative, and all of my positive y's become negative, and my negative y's become positive. So all of my positive r's become negative, and my negative r's become positive. So this point at the top would end up at the bottom. This point at pi over 6 would end up at 7 pi over 6. This one at 5 pi over 6 would end up at 11 pi over 6, and the entire graph would be below the line from pi to 0. So it ends up down here. The other thing I want to point out is the line of symmetry. If we were to draw a vertical line straight down here at pi, we would see that the graph looks the same on both sides of that vertical line. If I were to extend this graph out in either direction, I would also see that a vertical line at 0 or at 2 pi would also show symmetry on both sides of the graph. Likewise, if we look at the angles 0 and pi and 2 pi here, that also forms a line of symmetry where the graph looks the same on both sides. So for cosine, the line of symmetry goes from 0 to pi. And that gives me a horizontal line of symmetry. Now I'm going to call that horizontal kind of in parentheses because technically we don't really think about horizontal and vertical with a polar function. But this sideways line from 0 to pi is the line of symmetry for all cosine polar graphs. For sine, if we look at the sine graph, we see that it looks the same on both sides of the line at pi over 2 and also at 3 pi over 2. It looks the same on both sides of those lines. So if we see pi over 2 and 3 pi over 2, we see the graph looks the same on both sides of the line from pi over 2 to 3 pi over 2. So it has a vertical line of symmetry. So we notice that if we draw a vertical line through the polar graph that is a sine graph, it's going to look the same on both sides. And that's true for all polar functions containing sine and cosine. Now this is kind of an interesting little graph. This is a rectangular function that is just a horizontal line. In this graph, no matter what the x value is, the y value is always 4. So we can say the same thing in the polar function. For every theta, r equals 4. So no matter where I am on the graph, every theta has an r value equal to 4. So this just ends up being a circle with a radius 4 centered at the pole. Okay, so those are our circles in polar form. Notice that the number 4 here refers to the radius of the circle because it's centered at the origin. Here the value in front of the cosine or the sine refers to the diameter of the circle. Here's a circle with diameter 10. Here's a circle with diameter 4. In the next video we're going to move on to polar roses, which are taking the polar equation of a circle and extending it with an additional parameter.